the distributive property. In the last lesson, we saw the important properties of addition and multiplication, the commutative and the associative properties. So we're going to add a third property, and this is a pretty big one. It's the distributive property. So let's look at exercise 1. It says consider the product of 4 times 5. So if we were to multiply, 4 times 15, if we were to use the standard algorithm, that means, what were you taught in elementary school? Okay, so we would say, okay, 4 times 5, and we'd say that that's 20, and we carry that extra 10. 4 times 1 is 4, plus 1, or plus 2 gives us 60. So now it says represent the equivalent product of 4 times 10 plus 5 as repeated addition of 10 and 5, and find the product. So it says 4 times 10 plus 5. So that means I want 10 plus 5 4 times. That's repeated addition. So then if we could think about this, find the product. I would think, okay, groups of 10, 10, 20, 30, 40, 50, 60. Just another way of thinking about it, thinking about that repeated multiplication, or repeated addition to get to the multiplication. So we could think about, and what did I just do? I said 10, 20, 30, 40, and then I added on 10, 20. So 40 plus 20 is 60. Well, where could we get that 40 plus 20 from in a different way? We're going to see how our distributive property is going to come into play, which is kind of cool. So it says, exercise 1 shows the important property of being able to apply a multiplication to all parts of the sum. So this is what the distributive property looks kind of all fancy and mathy right there. So if we said that A, B, and C all represent real numbers are all the numbers that you know right now, including fractions and decimals and pi and all that kind of cool stuff. So what does the distributive property do? A times B plus, and then A times C. So if I were to look at exercise 2, it says evaluate each product by using the distributive property to make it easier. On B, okay, this one I'm going to let you guys do on your own and bring to class, express 18 as subtraction. So you're going to have to think about subtraction in that one that you're going to do on your own. So if I were to take 7 times 23 and think about the distributive property, I could think about it like this. 7 times 20 plus 3, because 20 and 3 give me 23. And now think distributive property. So that's 7 times 20 plus 7 times 3. So now I've got this group of 10, groups of 20. So 7 times 20, I think you guys are probably pretty good with that in your head, 140 plus 21, and that would give me 161. So if you did the standard algorithm like you were taught in elementary school, you would come up with 161. So I want you to think about B and try B on your own, but you got to think subtraction. So the distributive property can be used twice in order to multiply 2-digit numbers. For example, 12 times 28. I could simplify or break that apart and think about that as 10 plus 2, which is 12, and times 20 plus 8, which is 28. It just show each step in the calculation. And it says don't use a calculator unless it's to check. So let's play this game. So 12 times 28, and they said, okay, well, 2 times 10 plus 2, times 20 plus 8. So if I'm going to use the distributive property twice here, I've got to distribute that 10. So I would say, okay, well, what is 10 times 20? And then I'd have plus 10 times 8. And then I would have to distribute the 2. And I'd say plus 2 times 20 plus 2 times 8. Okay, so now I end up with, just got to pause for a second, somebody's knocking at the door. Okay, I'm back. So 10 times 20, 200, plus 80, plus 40, plus 16, which would give me 336. So we just double distributed. So we played a little game there with our multiplication to involve this property. So go ahead and now let's apply some algebra to this. It says the distributive property can also be used on expressions. Okay, so expressions don't have any equal signs in them. Express the following products as binomial expressions. So binomial means we have two terms. And an expression means no equal sign. It's not an equation, okay? It's an expression. So distributing 5 times 2x is going to be 10x. And then 5 times 3 plus 15. There's two terms, 10x and 15. That makes it a binomial. No equal sign. It's not an equation. It's an expression. You're going to do letter B and letter D on your own. And then we'll take a look at letter C. Do the same thing. X times x. X times x. Now, x times x is going to be x squared. Don't think x plus x. X plus x is 2x. Remember, we're multiplying. And then x times 4 is plus 4x. Again, x squared, 4x. We have two terms, so that makes it a binomial. You're going to do B and D. Now, let's look at some in general. It says one common mistake students make is not realizing that the distributive property works for division as well as multiplication. So what does it then look like? So I have this division, B plus C, all divided by A. So I could rewrite this and B divided by A plus C divided by A. So that's still the distributive property, and it says of a division over addition. So let's practice with that. It says express each of the following quotients. Quotient means to divide as binomials in simplest form. Show your calculations. Some of your final answers will contain fractional coefficients. Okay, coefficients are just the numbers in front of your variable. Okay, fractional coefficients, and that's okay. All right, so we're going to do A. So again, applying that distributive property. So I'd have 8x divided by 2 plus 4 divided by 2. Now I can simplify. 8x divided by 2 is going to give me 4x plus, and then 4 divided by 2 is 2. So that would be my final answer. I've still got my binomial there. You are going to do B and bring it to class. D, we're going to do together. Again, 2x divided by 4 minus 16 divided by 4. Simplify your fraction. So that becomes 1/2 x minus 4. Fractional coefficient, 1/2, that's still acceptable. You also could write that as x divided by 2 minus 4. That 1 that's not written there, it's understood that it's there. You're going to do D. And then if you would skip over, so bypass the homework because we're going to do that in class, and skip over to the next lesson, lesson 5, let's talk about some equivalent expressions. So the idea of an equivalent expression, okay, equivalent, it's got that prefix in there, that's going to mean equal expressions, or equivalency is important. It is the basis of many, if not most, algebraic manipulations. So things that we're going to do to these expressions and or equations this year. So equivalent expression. Two or more algebraic expressions are equivalent if they have the same value for every value of the substitution variable or variables. In other words, no matter what value you stick in for x or y or z, whatever your variable happens to be, the two expressions will come out to be equal. So I've got this table here, so let's kind of play around with these three expressions that are written along the top, and then these three values of x. So we're going to figure out which two of these are equivalent to each other. So you might be looking at them and you might already be able to pick out which two are going to be equivalent to each other. But let's play a little number game here. So it says if this is my expression and I need to substitute x in, and my x is 7. So doing the substitution, I get that. And then I could play the distributive property game, or I could think about my order of operations. Either way, it's going to get me to 5 times 4, which is 20. So now when I take 7 and plug it into this expression, 5 times 7 minus 3, 35 minus 3, and that leaves me with 32. So right now, this is 20 and this is 32. It looks like these two are not equivalent. So let's see what happens with this third expression. 5 times 7 minus 15. So that's 35 minus 15, and that's 20. So winner, winner, chicken dinner, we have got this is equivalent to that. Okay, the distributive property was just done to that expression to get this. I would like you to substitute in 0 and see what happens, and then also substitute 1 in and see what happens. Okay, so as we move down, let's take a look at exercise 2. Which property, commutative, associative, or distributive, justifies, okay, the equivalency of the two expressions you determined to be equivalent above? I think I mentioned that. Okay, what property justifies why these two expressions are equivalent to each other? They're equivalent because of the distributive property. Okay. Because 5 times the quantity of x minus 3 is most certainly equal to 5x minus 15. Exercise 3, it says, which of the following expressions is equivalent to this? Show your work to justify your response, and then they're asking you to test at least one value of x to check your answer. So when I take this expression, I'm first going to start and I'm going to distribute, and I'm going to say that that's 10x plus 5 distributed, then minus 4. Then convention says I need to combine my like terms here to simplify, so it's 10x plus 1. So now they're saying, okay, we'll test a value. So I'm going to pick a nice value. I'm going to pick a pretty easy value to work with. I might test 1 and see what happens. So when I put 1 into my original expression, I'm just doing the substitution now. Now I've got to do a little mental math here. So I know my parentheses, 2 times 1 is 2 plus 1 gives me 3. 15 minus 4 is 11. All right, so I know that that equals 11 when I plug 1 into my original expression. So now let's do the same thing into my answer that I got when I distributed and combined like terms over here. So does the same thing hold true? 10 times 1 plus 1. 10 times 1 plus 1, absolutely, those two are equivalent. So I distributed correctly, I combined like terms correctly. This test value told me I did my work correctly. Even if you picked a different number, say you picked 0, because 0 is pretty easy to work with, what you would end up coming up with two equivalent expressions. So the answer to that is going to be that 10x plus 1. Go ahead and flip the page, and I'm going to have you do exercise 4. Okay, it is a multiple choice, but it also does say, finally, check your answer by substituting a value of x. Why don't you work with a test number of 0, because 0 is super easy. Then in exercise 5, it says the last exercise is an example of an expression with a fair number of operations within it. Sometimes it is just as important to recognize more simple equivalencies. So it says, which of the following expressions is equivalent to this? Explain how you made your choice in the space provided. So I'm looking at this, and then I'm examining my choices, and I'm saying, looks kind of the reverse of what we've been doing. Down here in my choices, it looks like some distributing needs to be done, but up here in the original problem, it looks like maybe distributing has already been done. So what we're going to do is we're going to do something called reverse distributing. And reverse distributing has a particular name, and it's called factoring. You will hear me say factoring a bazillion times this year, okay? So when I look at this, I say to myself, okay, kind of examine these, and I look and say, okay, 10x and 15, what do they have in common? I see a common 5, so I might be drawn to this one or this one, and then I might play the distributing game, and I say, okay, 5 times 2x, that's 10x. Ooh, so far so good. And then 5 times 3, 15. There's my winner right there. And if you go through and distribute any of these, it's not going to be equivalent. So it says the last problem is known as factoring. Factoring is the process of writing an equivalent expression as purely the product of other expressions. Product means to multiply. So you're showing that multiplying two expressions. So factoring will be one of the most important skills that we want to reach fluency with. Okay, we want it to become automatic. Okay, so remember that it's the reverse of the distributive property. So I'm going to do one more down here. We're going to do the same thing. We're going to factor it. So what do these two terms share in common? What factor do they share in common? And they share a 3 as a factor in common. So when I reverse this distributive property, 3 times what gives me 6x, and I know that's 2x, and 3 times what gives me 21, a positive 21, it's that, and they're asking you to check it by distributing. So do the check and distribute. 3 times 2x is 6x, 3 times 7 is 21, and that certainly matches our original problem. You are going to do B and C and come to class. So pause the video, go back and do the problems that we've circled that I've asked you to come to class with. Rewatch some things if you need to. Come prepared to work tomorrow in class. We'll see you guys tomorrow. Have a good one.